All right. So we just looked at how to determine if functions are even, odd, or neither using our graphs. And now we're going to do it algebraically. So a function f of x is even if f of x equals f of negative x. And a function is odd if f of negative x equals negative f of x. It is neither if neither of these situations is true. And a lot of functions are neither, so that's okay. The way we're going to set this up is in a pretty simple 3-column table. The first column is the easiest. F of x is the original function. You leave it as is, the function as it was given. In the middle column here is f of negative x. So what we're going to do in this middle column is plug in negative x into our function and simplify. Okay? So I'm going to say plug in negative x and simplify. All right. And our last column over here is negative f of x. So looks similar, but very different from the middle column. Negative f of x is essentially putting a negative into the entire, distributing a negative to the entire function. To the entire function. All right. And that could look different based on what the function is, but that's why we're going to do some examples. Let's jump in. Oh, by the way, I should say. So from these 3 columns, you would tell if a function is even is if f of x here is equal to f of negative x. This would be an even function if those 2 columns are exactly the same. And if that's the case, you're done. It's even. If they're not equal, then you go on to the next step and you compare f of negative x with negative f of x. And if those 2 are the same, then it's odd. If none of them are the same, then it's neither. All right, those are your 3 situations. Now let's jump into it. So here I have some functions. I'll start off up at the top. G of x. This is my original column right here. So g of x, it's already written. Great, I'm done the first column already. My second column is going to be g of negative x. My third column will be negative g of x. All right, and let's see where these take us. Okay, g of negative x means plug in negative x in for every x in my function. So this is going to be negative x to the 4th minus 2 times negative x squared. Now, the ruling with exponents, if you're squaring a negative number, it becomes positive because you're multiplying a negative times a negative. If you are raising any negative number to an even exponent, it becomes positive because you have an even number of negatives. So they'll always cancel each other out. So what that means is negative x to the 4th, in parentheses there, parentheses are very important, negative x to the 4th is just simplified to x to the 4th. Minus 2 times negative x, in parentheses, very important, squared is just minus 2x squared. The negative stays on 2 just because it was there. That is my simplified form. So g of negative x is equal to x to the 4th minus 2x squared. Simplified, good. This will always take you 2 steps, okay? It will always be plug in the negative x to each x value, then simplify. Plug in, then simplify. And now you look, okay, does this match this? It does. So if that matches, it's even, and I'm done there. You have to show your proof. You cannot just jump to saying it's even. You have to show your algebraic proof like this. Since that happened, I know it can't be odd. I don't have to do that. All done. Number 2. Now I have f of x. So I have my original function. This is column 1. Great. My second column, and I'll try to use colors to keep this somewhat organized. My second column is f of negative x. And my third column is negative f of x. All right. So f of negative x, let's do the exact same thing again. I have, this is going to be tight, 2 over negative x to the third plus 1. All right. That's step 1. Plug in the negative x. Step 2 is simplify. So the 2 on top, there's nothing to be simplified. The x on bottom, though, I can. Negative x to the third. If you raise a negative number to the third power or to any odd power, it is still negative. Negative 2 to the third is negative 8. So this is going to simplify to 2 over negative x cubed plus 1. That's my simplified form. I'm going to circle this just so I got it there. All right, compare it to the original. Are they the same? No, they are definitely not the same. So I need to keep going. I'm going to go to my third column here. I'm going to take my entire function, which is this whole fraction, and I'm going to put a negative out in front. This is step 1 in my third column. Again, always requires 2 steps. Now you need to distribute it in. And here's where, especially in this problem, we have to get creative and we have to be thoughtful with what we're doing. When you have a negative on the outside of a fraction, you do not distribute it to the top and the bottom. Think about 1/2 with a negative out in front. If you distributed that negative to the top and bottom, you would have negative 1 over negative 2, which would cancel and become positive. Do not distribute to the top and the bottom. You choose to distribute to the top or the bottom, because negative 1 over 2 is the same thing as 1 over negative 2. And you have to choose because you want to make it match your previous column. So when I look at my previous column, this f of negative x, the middle column, I see a negative x cubed on the bottom. So let's try to distribute to the bottom and see if I can get it to match. So when I distribute this negative into the bottom, I need to distribute to both terms. And that would end me with 2 over negative x cubed minus 1. There's simplified form. Do not forget to distribute. You distribute to the binomial on the bottom. So that negative 1 versus this positive 1 means they do not match, which means this function is neither. Last one, squeezing it in here. All right. Same process. H of x, first column is done for me. Fantastic. Now, h of negative x, and then negative h of x. All right. H of negative x means put a negative x in for each. And simplify. Negative x cubed gets me negative x cubed. Plus negative x, the same thing as minus x. So that's my simplified h of negative x. All right, let's see. Does that match my original? Definitely not. So let's keep going. H of negative x is going to be negative the whole function. All right, distribute in. Always a first step, then a second step. Distribute the negative in to both things here. In terms of so because h of negative x And negative h of x can be simplified to the exact same thing. This function is odd. So, all right, we have an example of even, an example of neither, and an example of odd. Your turn to try a couple out. So I want you to pause the video, try these three out, use the same strategies I did. Make sure every column requires 2 steps, right? First step, and then simplify every time. So pause and try it. Show the answers. No. Here we go. Sorry for the chicken scratch, but the first function is odd because g of negative x and negative g of x are the same. Second one here, number 5, is even. And the 6th, or the last one there, is neither. Good job.